All right, we're starting on page 577. We'll be going to 580, and again to our assignment on 581. So this is module 4, topic 2, and the second part of lesson 2. So we're now applying the Pythagorean theorem and its converse to different contexts or story problems. So, it doesn't give us some type of nice triangle for us to figure out, or right triangle. We have to create this image and figure out to answer the question. So, number 1. It says a carpenter attaches a brace to a rectangular picture frame. When the picture frame dimensions are 30 inches by 40 inches, what's the length of the brace? So, this right here is the brace. We'll draw that line. And we're saying that the side lengths are 30 and 40. Now, one of them is 30, one of them is 40. We're going to say the one that looks like the shorter side is 30, this one is 40. This other one we'll just say is C. We don't know what that is for now. But how long does that have to be so that that picture frame forms some type of right angle? Otherwise, it's going to be slanted, and a picture might not be able to fit in this frame. So plug this into the Pythagorean theorem, right? A squared plus B squared equal to C squared. Let's say A is 30 and B is 40. So 30 squared plus 40 squared equal to C squared. Right, 30 squared, like when you do 30 squared, what I do is I do 3 squared, which is 9. And when you have this squared, the square tells you how many zeros you have to put, so it tells me to put 2 zeros. So try it for 40, right? What do you think 40 squared is? I'm going to square the 4, which is 16. 4 times 4 is 16. And I'm going to put 2 zeros. And this is equal to C squared. Now we add, right? This will equal 2,500 or 2,500. And at this step, we know to take the square root of both sides because I want to get rid of the square that's here. I'll put C on the left side. And, when we're looking at what number times itself will equal 2,500, we could plug this into the calculator, but this is 50. Right, so the length of that brace has to be 50 inches. Okay. Now, we could have figured it out by using the Pythagorean theorem, but I want you to understand from the past lesson we talked about 3, 4, 5 being a Pythagorean triple, and we had 30, 40. How could we have figured this last number? We talked about how Pythagorean triples, anything is a Pythagorean triple if it's a multiple of an existing triple. So 3, 4, 5, we multiplied by 10, right? 3 times 10 is 30, 4 times 10 is 40, 5 times 10, that gives us 50. So this is a matter of being efficient and using patterns or pattern recognition to help us. But we just use the formula to figure this one out. Okay. All right, let's go and move on to number 2. So it said Bill uses rope to outline a location to build a rectangular deck. So when we do this, just draw a rectangle. It's not a square. If it were a square, it would have said square, but it said that should be 8 feet wide and 15 feet long. We're going to say this one is 8 because it's shorter, and this one is longer, so we'll put that as 15. His friend Tyrone lays a 15-foot long board on a diagonal of the deck area Bill outlined, and it just fits from corner to the opposite corner. So corner to the opposite corner. So opposite corners here. What should Tyrone tell Bill? So, how long is that diagonal there? So in this case, this is C. We're already saying that it's a rectangle, so we know that this is 90 degrees. 90 degrees have right angles. And we'll plug into the Pythagorean theorem. So we're going to have A squared, which is 8 squared, B squared, which is 15 squared, and C squared as is. This is another Pythagorean triple. There's a Pythagorean triple that states it's 8, 15, something else. So if you have a list or maybe in our guided notes, you can already find out what the answer is to this one. But let's go through the process. This is 64. 15 times 15 is 225. And c squared. These two values, if we add them together, is 289. And if you take the square root of both sides, the square root of 289 is 17. Right, so this is 17 feet. That's equal to C. Right, so the diagonal of the area of Bill outline should be 17 feet if you correctly place that rope. Because the 15-foot board fits when where the hypotenuse should be, Tyrone should tell Bill that the deck is not a rectangle. The corners of the deck are not right angles. So he's got to be careful with that because it should be 17 in order for that to be a right angle. So we use the converse of the Pythagorean theorem. All right, moving on to number 3. The diagonal measurements of the screen identifies a television. So when you buy a television, if something says it's a 36-foot screen, when it means it's the diagonal of that screen, it's not the width of it. This is what it means. So if something is like, let's say a 300-inch screen, it's the diagonal of it. So whenever you buy televisions, or screens, or monitors, or laptops, whenever it tells the dimension, it's the diagonal. Anyways, so it is 36 inches, whose height, the height of this screen is 22 inches. We want to know what is the width of the television screen. We're going to round to the nearest inch. Okay, so this, we don't know. This is either A or B because it's next to the right angle. We'll just put that this is A. All right, so let's plug in 22 for B and 36 for C. So this will be A squared plus 22 squared equal to 36 squared. All right, we're going to get A squared plus 22 squared. What is 22 times 22? Let's figure that out. 22 squared, that's 484. What is 36 squared? 36 is 1296. So 296. And when you solve a problem like this, we're trying to isolate for A, so we're going to subtract. We're going to subtract 484 to both sides. We're going to get A squared is equal to 812. If we take the square root of both sides, A is going to be approximately equal to, so we have to find the square root of 812. Let's clear this out. 812 square roots. So it is 28.49. We'll go to the 5, so 496. That 6 makes that 5 go up. So 28.496. And this is in terms of inches. Now, it said round the answer to the nearest inch. So does this round up to 29 inches or stay at 28? It's closest to the nearest inch. It's closest to 28 inches is the length or width of the TV. I will say is the width of the TV. All right, so we answered that. Let's go and move on to the next page on 578. Right, so generally these problems that don't have like a picture, those are the ones that are a little bit harder where we don't have a visual. Like the visual really helps us to determine which one is A, B, or C. So we just have to be careful with that. Let's go with number 4. So it says Orville and Jerry want to put a custom-made round table in their dining room. The tabletop is glass with a diameter of 85 inches. The front door is 36 inches wide and 80 inches tall. Orville thinks the tabletop will fit through the door, but Jerry does not. Who is correct? Okay, so you know what? For right now, let's just draw this door here. Now, if we're making, if we're trying to put together, or we're trying to put this like round disc or glass top through here, so imagine we're trying to carry this like big circle through this door. The way you're gonna have the most room is if you try to fit it right here. Right, so it's kind of like where we have like, I want you to imagine like this disc really slanted, where it's almost like perpendicular to the door frame. Anyways, so this is saying it has, the glass top is 86 inches in diameter, so this, or sorry, 85 inches. And let's put the dimensions of the door. We said that it is 36 inches wide, and it is 80 inches tall. Okay, I'm going to use this triangle here on the top left. So we know that the hypotenuse is 85. We're going to use that for C. We'll use the other values for right, A and B. So we have to see if this is equal, then it'll like just fit. If it's less than or more than, we'll see if it has enough room or not. Okay. All right. So it's going to put A squared plus B squared equal to C squared. So A squared is 36, B squared is 80 squared, and C squared is 85 squared. Okay. So it's going to multiply these things out. So what is 36 squared? She did that earlier. Is 1296. I'm actually going to use that tip that we learned earlier. Oh, there's an issue here. 80 squared. I'm going to put 8 squared. 8 squared is 64, and I'm going to put 2 zeros because of the square. 85 squared. Let's do that. 7,225. So 7,225. And let's add what is to the left. I don't know, my screen keeps messing up. If you add these two values here, let's go ahead and line this up. Or we're gonna get 6, a 9, a 6, and a 7. So 7, 6, 9, 6. Okay. So what this is saying is off to the left, right? Everything to the right of the equal sign is the door. Everything to the, sorry, left is the door. To the right is that glass tabletop. So we'll just put glass. Since this number is bigger or greater than this number, that means we have enough room for this tabletop to fit. So in this case, we're just going to put they can fit the tabletop through the door. Or that would be unfortunate. Otherwise, they'd have to like get a refund on that tabletop. Yeah, and we could take the square root of both these numbers. We'll still find that the left side is greater than the right side. So this is good. So in this case, Orville thinks the tabletop will fit through the door. Orville is correct. Okay. We're gonna skip number 5 and go to 6. And they'll probably call it there. Verona places a 10-foot ladder 4 feet from the edge of a building. How far up the building does the ladder reach? So, right, this is all in our interpretation of the situation. So I'm gonna draw the ground. I'm gonna draw this building. Okay. And we have some type of ladder here that's leaning up against that building. All right, let's put some numbers from here. So it says the 10-foot ladder, so what's in pink is 10, is 4 feet from the edge of the building. So this distance on the bottom, the base of it is 4 feet away, even though my drawing probably isn't up to scale. This building is upright, so we know it's 90 degrees, and we want to know how far up the building does the ladder reach. So we don't know what this distance is. I'll put that that's x. Round the answer to the nearest tenth of a foot. So we're going to put a squared plus b squared equal to c squared. So this is going to be, let's put 4 as a, so 4 squared plus b has to be x equal to 10 squared, right? Because that's the hypotenuse. 4 squared is 16. We'll keep this. 10 squared is 100. And if we're trying to solve this equation right here, I have to move everything away from x or x squared. So we have to get rid of this positive 16. I'm going to subtract 16 on both sides. And when you subtract with consecutive zeros, like you can't take away 6 from 0 and get a positive number. You're going to get negative 6. So I can take away, not from the 0, but I take away from the 10. 10 minus 1 is 9. So I took away 1 10, but I'm going to add 10 ones. 10 minus 6 is 4. And then the next one is 9 minus 1 is 8. So when I go through that process, we're going to take the square root of both sides. We're going to get x is equal to, this won't be a perfect square, so we're going to have to approximate. And keep in mind, we're rounding to the nearest tenths place. So square root of 84, square root of 84 is 9.16. We look at this 6 to tell that 1 to go up, so it is 9.2 for that. 9.2, and this is feet, right? So 9.2 feet up this building. So that's about the height of our class. Our class is like 9 to 10 feet. So that's how far it's going to reach up that building, okay, on the outside of that building. All right, and then we're gonna let's go. Let's finish up on number 7. We're gonna skip the next part. It says Chris has a tent that is 64 inches wide with a slant height of 68 inches on each side. What is the height of that center pole? So the slant height means it's the diagonal here. So that is 68. Right, and we're saying that the opening of it is it's saying it's 68 inches, or sorry, 64 inches wide. So this whole thing is 64. We have to be careful with this. Actually, I'm gonna bring that down. If this whole entire thing is 64 inches, how much is half of that? Right, what's half of 64? So actually our opening here of this triangle, the width of it is actually 32 if you divide 64 by 2. So this, we're going to use 68 for our slant height, or that is C, our hypotenuse. We'll say that this is A, and we want to find what is B for that height. Okay, so let's go and rewrite the formula. So we're going to have A squared is 32 squared. We keep B squared, and this is 68 squared. Let's simplify. 32 times 32, I'm just going to give that to you. That is 1,024. 68 times 68 is 4,624. And if we subtract this to both sides, or we typically subtract when we're trying to find the leg of a right triangle, we're going to get b squared equal to, if you subtract this, notice 4 minus 4, 0. 2 minus 2, 0. 6 minus 0 is 6, and 4 minus 1 is 3. And when we take the square root of both sides, b is going to actually be a perfect square because the square root of 3,600, or you could think about it as what's the square root of 36? Square root of 36 is 6. And we're going to add a 0 here. So our final answer is going to be the height of the center pole is 60 inches. Okay. The rest of the activity 3 we're going to skip. We'll say that that's a you do. We're not going to do the talk, but the assignment you're going to do all of number 1. Let's do number 2, but not C. So we'll say number 2, A, B, and D. And then 3 is just one problem, so we'll keep 3. So number 1 all, 2 A, B, and D, and 3 just by itself on page 580. Okay, let's go and get started. Let me know if you have questions.